part 2 of circle geometry, sorry. Question 7, we're looking at what theorems we can use to help. So look at the diagram, notice, I mean, there's no center of the circle, so no radius, there's no tangent, so we're ruling some of that stuff out. There's no going through the diameter, okay, which means first two, no. Second one, no tangents, no angle at the center, right? It's a bit of a process of elimination. So really it comes down to angle subtended by the same arc. So have we seen what I like to call the bow tie, crisscross? Crisscross will make you jump, wiggle, whack. So we can see here that very clearly we've got the bow tie happening. So this angle has to be the same as this one. So that's got to be 43. Well, how does that help us find x? You can do, there's 180 degrees in a triangle, but I would like to remind you or tell you about one of our theorems, and it should be on the sheet that I've given you, but it's called exterior angles of a triangle. So if I've got A, B here, this angle here is always going to be A plus B, right? You can turn the triangle around any way you want. So if I extend, see here how I've extended there, so this one and this one would equal that one. Okay, so in this case I would say 43 plus x would have to equal 92. So have a go at writing that up. So pause the video, see if you can write that up, and then have a look at what I've done. But again, mine is just one way. And please remember that if you didn't want to use exterior angle of a triangle, you could have absolutely said, well, I can find this angle here because there's 180 degrees, so 180 take 92, and then we have to add all of these up to equal 180. You'll get the same answer, it's just one more step. Okay, so pause, do your solutions, then compare them to mine. They don't have to be the same, but do they flow? Okay, so my solution is I'm going to start by saying angle SRT equals angle PQT. And you could have said PQS, it's all the same, right? And Y, you can say angle subtended. I like to say angle same arc. Okay, and that is 43. And then we can finish that off by saying, therefore, I guess I should say the angle TRS plus angle TSR has to equal PTS. In other words, 43 plus x has to equal 92, and then you can solve that for x. Okay, next one. Again, it's about matchy-matchy and noticing what do you see. So look carefully. First thing I see is that it's going through the center, so I've got the diameter. All right, diameter, triangle, so bang. I know that's got to be 90 degrees. Okay, we've just done D, where you can see the bow tie crisscross. So again, I can see that crisscross, and so if that's x, then this has to be x. And now I've got 3 angles of a triangle. We should be able to write that up. So again, please stop the video, do your write up, and then compare. Okay, that was my write up, and obviously just finish. So again, yours does not have to be the same, but can you understand what I've written? Can your neighbour read what you have written and it makes sense, and you've definitely put your reasoning? So hopefully by this time you're just sort of going through and you're having a go. Again, please stop the video and try yourself, then have a look if you get stuck. All right, so F. What's going on? Again, I am looking at, I've got parallel lines here and I've got a tangent. Okay, so go back to mine. There's no center, there's no radius or anything. So I'm looking tangent. I've got this one. And remember your parallel line stuff. So go back, look at that sheet that you have, and we should see we've got our parallel lines, and so we know that this angle is the same as this because of alternate, which means I can say this angle is the same as this one. Okay, how does that help me? Well, because your tangent is the clear winner here, I'm going to apply this rule, and so we're saying, well, we've got this one, it's not the next, but it's the next one after that angle. Okay, so this one, it's not this one, but it's the next one after. So if this is x, then so is this. You could also look at it that, oh no, you couldn't, I was going to say this, there are two angles inside a parallel line, so they add up to be 180, but we didn't know that. So anyway, so yeah, that would also have to be x because of tangent chord theorem. You write that up and I will have a look at that when I come back, so do your best. And last but not least, G, again, pause that video. What do you see? Got the semicircle thing there, so not only is that a right angle, but you can see I've got another right angle there. I can see that we've got an isosceles triangle. I don't know how that helps at the moment. What can we do? Can we see crisscross here? Okay. So again, every time that I give you a hint, stop the video. Don't just keep listening to me because I just can't keep pausing. You've got to sort of go ahead. So if that's 20, then what else will be 20? I hope you've said proudly, yes, it's that one. And so now we're using our isosceles triangle to say that that angle is the same as that, and therefore add them all up together. It has to equal 180 degrees. Okay. So when we did this, what did we actually use? We didn't really need that one. It was mainly this. So we're going to start, you don't have to put, and that's the other thing, don't put every single thing, every property that you find in your proof, because that's then just confusing for everybody. So angle ACD equals 90 degrees, right? Y angle in the semicircle. And then what did we do? We said that this was 20, which means that was 20. So angle CDB equals angle BAC, which was 20 degrees. Okay, and again, why was that? So angle same arc, subtended from the same arc. Okay, and we can say, oh, I will write and angle CDA equals angle CAD. Okay, why is that? Because we've got an isosceles triangle, and that was given to us because we had the two sides the same there. All right, so therefore, do you want to say the angle this plus angle that? I mean, might as well. So angle ACD plus angle CAD plus angle CDA equals 180 degrees because there's 180 degrees in a triangle. Now, part of me is sort of thinking, should I have written somewhere there what angle CDA is? Maybe over here, equals x plus 20, and that's just so people who are reading my proof can follow. All right, and so then underneath, that's going to be the 90 plus x plus 20 plus x plus 20 equals 180, and you can take it from there and solve, and there's no reasons needed. Okay, and last one. Let's have a look at this one. So again, we're looking, I don't see parallel, but again, what's the key word here? Tangent, and this time I do have a center of a circle. So, you know, look at some of the things that are happening there. Have a look at your theorems, what's going on, what could you do? Remember, one of the tips that we said with angle at the center is then look for radius. So when you've got a center, look for the radius, so we can see we've got radius happening here, and straight away that means that I have an isosceles triangle. So XX. Still don't really know how that's going to help with our diagram. Okay, so keep looking. What do you see? We've got radius, we've got tangent. Now, some people want to try and use this, but you can't use this one, the tangent chord, because notice all the vertices of the triangle have to touch the edge of the circle. And look at yours. Is that the case with this triangle? No, it is not. Right, so that one's ruled out. And you go, oh dear, what's happening? Well, radius, tangent. Where else do we see a tangent? No. Oh, yes, but that doesn't help. Oh, hello, this one. We've got radius, we've got tangent. So that means this angle here must be 90 degrees. Again, try and think what's going on. I'd like you to look at maybe the bigger triangle. Like, could you find this angle here using the little one, and then knowing that the big one is, you've got two of those angles there, right? So using 180 degrees in a triangle, let's see if you can work that out. So again, hope you've paused the video. I'm sort of stopping here and it's just blank air. But anyway, so if you're looking at the little triangle, we've used up x, we've used up another x, so this would be 180, take 2x, yeah? And then if you're looking at the bigger triangle, then we know that this angle plus this angle plus this one has to equal 180. So you would end up, so do your proof and you'd have that 180, take 2x plus the 90 plus the 20, that equals 180. So they sort of cancel and then away you go. You should be able to solve. So please go back over, have a look. If you really want more practice and try and do some without, go back to the scooch down in the textbook and there's some review questions. You can pick some of those to have a look at, but this will probably fill the lesson, and then obviously it's your investigation that you can work on. All right, hope that's so good. I'll chat to you next lesson.